It's math time with Heinz. It's math time with Heinz. It's math time.
Hi everybody, now that we're towards the end of our function unit, let's spend some time to practice here and go over these practice problems you've completed. So number one, which relation is not a function? Well, what makes something a function is every x corresponds to only one y value. I can't have an x going to two different y values, that's bad. So when we look at our table, we check, do our x values repeat? Nope, we're good. So that is a function. 3, you could throw that in your calculator, or you can notice that's a y equals mx plus b. That's a line. Lines are functions. C, when I have a graph, I can draw vertical lines and do the vertical line test and see that that is a function. Where do we go wrong right here is 2. 2 is getting sent to A and 2 is getting sent to B. That one x value has two different outputs. So the function g of x is defined as negative 2x squared plus 3x. What is the value of g of 3? Whoa, we're sliding around here. G of negative 3. Sorry, that's my x value. So that's the value I'm going to plug in. Again, you could use your table on your calculator here. That'd be a really smart way to not have to do any math here. But now I just need to type that into my calculator. Negative 2 times negative 3, close it, squared, plus 3 times negative 3. Done. Negative 27. I used my calculator. I used my graphing calculator to get the solution, to get the output. Negative 3 is the input. Negative 27 is the output. What is the domain? Well, when I talk about domain, I'm talking about my inputs, my x values. So it wants to know what are all the x values of this relation here. 4, 1, 0, 1, 4. 4, 1, 0, 1, 4. It looks like A. Domain is my x value, my input. Notice this isn't a function because your x values repeat. X equals 4 goes to two different outputs. What is the minimum value of this function? So let's look at a graph. Y equals the absolute value of x plus 3 minus 2. So y equals, I'm going to hit math number, there's abs, absolute value of x minus 3 plus 2. And do I want to know what is the value or when do I get to that value? What is the value? So I want to know how low do I go? Well, it looks like it's that turning point right there. So let me go to my table. What's the smallest y value? 98765432342. 2 is the minimum value. I used my graphing calculator right there. 2 is the lowest. I typed it in wrong. I typed in the equation wrong here. Ignore me. Math, scroll over. Absolute value of x plus 3, close it, minus 2. I can't believe I typed it in wrong. Redo. So notice it's over here now. How low do I go? I need to look for the lowest y value. 5, 4, 3, 2, 1, 0, negative 2. Negative 2 is the y value, the lowest value there. I have to hit myself. Bad Heinz. That was a bad Heinz moment there. The functions f, q, and p are shown below. So I got f, q, and p. When the input is 4, which functions have the same output? So I'm plugging in x equals 4. My input is 4. The output here is 3. The input is 4. I'm going to go over to 4. What's my y value? 4, 3. So I'm looking for 4, 3. Is that on this graph here? Let's do 4 minus 1 squared minus 6. 3 squared minus 6. 9 minus 6 is 3. Notice all of these functions here, f, q, and p, all have an output of 3. When I plug in a 4, the output is 3. If f of n, which is the same thing as f of x, they're just using n instead, equals x minus 1 squared plus 3x, which of these statements is true? So now I could do all these by hand, or I could be smart and use my table. So let me go to my calculator and see if I do better typing this function in. Parentheses, x minus 1. I can't use n, so I'm going to use x. X minus 1 squared plus 3x. I'm going to go to my table and see my table of values. There. F of 3 equals negative 2. When I go to 3, does it equal negative 2? No, 3 outputs a 13. It's not choice A. Negative 2, let's go to negative 2 in the table. -2, comma 3. When I plug in a -2, the output is 3. Choice B. When I plug in a -2, the output is 3. Here's a nice parabola that's upside down U-shape there. Is this a function? Well, if I draw vertical lines, I only hit it once. So this is a function because it passes the vertical line test. We use the vertical line test to see if something's a function. Does every x value hit the graph only once? Again, hopefully you're good at this function notation. How do I find f of -3? Well, 4 times -3 plus 5. -12 plus 5 is also known as -7. -7 is the output. So whatever that input is in the parentheses, and we plug it in for x. A mapping is shown in the diagram below. Is this a function? January goes to 31. February goes to 28. Ooh, not bueno. February cannot go to both 28 and 29. So this is not a function because that input has two outputs. I don't care that they're both going to 31. March and January can both go to 31. That doesn't bother me. It's that February splitting there going to two different places. All right, the table below shows the year and the number of households that had high-speed internet access. For which interval was the average rate of change? Average rate of change is slope. Change in y, y2 minus y1 over x2 minus x1. So again, I'm giving you the x values here, going from 2002 to 2004. So 11 minus 23 over 2002 minus 2004. So that change, that went up how much? That went up 12, -12 over -2. All right, let's try the next one. Unfortunately, we got to do them all here. 2003 to 2005. So let's do that. 16 minus 33, y minus y over 2003 minus 2005. -17 over -2. So that's bigger. This is bigger. 2004 to 2006. So 23 minus 42. It's really nice that all the denominators are -2 here, because that just lets me compare the top numbers. -19 over -2. That's even bigger than all those other fractions. And then finally, 5 to 7, 33 minus 47 over 2005 minus 2007. So -14 over -2. So who was the smallest here? That first year was the smallest. That rate of change there was the smallest. So sometimes you got to do average rate of change 4 different times to go through all the choices. Which interval represents when the child was constantly moving home? So a child is playing outside. The graph is the distance from home. So when am I moving closer to home? That's when I'm decreasing. When is this graph decreasing? When am I going down the roller coaster? Well, right there. So from 0 to 2. Other than that, it's going back up the roller coaster. Here I'm staying constant. That's constant right there. It's not changing from 4 to 6, staying at the same distance. Looks like we've got another average rate of change question here, so I'm doing slope between the original photo and the fourth. Original photo and the fourth. Well, how do I do average rate of change? Well, I subtract my y values, 36 minus 15, over my x values. Well, I put 36 first, so 4 is going on the bottom first. And then from here, I just type that ratio into my calculator. So math fraction, and I'm going to type in 36.6 minus 15 over 4 minus 0. So we get 5.5. We get 5.5 as our average rate of change when I type that into my calculator. Calculate the average rate of change. Same thing, we're finding slope again. We're finding slope, the average rate of change from 3 to 9. So 3 minus 9. I need the 3 value and the 9 value. So 6.26 goes with the 3, minus 3.41 goes with the 9. And then I just type that whole ratio into my calculator. I'm going to make a fraction. I cheated there. 6.26 minus 3.41 over 3 minus 9. Boom, that's my average rate of change, negative 0.475. The average rate of change there is negative 0.475. That's the average rate of change. 4 relations are shown below. Who's a function? So let's go them one by one. All right, I see a graph here, so I'm going to draw in vertical lines. So that looks like a problem, but I've got an open circle. Open circles are okay. I'm only hitting it once. Again, open circles are okay. This right here is not okay. 2 closed circles is bad. 2 closed circles, that means I hit it twice. Open circles are kind of like a little hole that you fall through. You get to skip through them. You're not really touching the function there. So here I have 2 closed circles. That's no good. So this one is not a function because 1, 2, 3, 4, 5, 6, x equals 6 has 2 outputs. Let's look at our table. We check our x's. Negative 4, 0, 4, 6. That's good. This one is good here because my x's didn't repeat at all. Let's check number 2 here. 1, 2, 3. Oh, 2 goes to 5 and 2 goes to negative 5. 2 is splitting there. 2 is going to 2 different outputs. So x equals 2 has 2 outputs. Not 0.0. Not good. Y equals x squared, I can throw in my calculator. Y equals x squared to look at a graph of it. And it's that U-shaped. And that is good because it passes the vertical line test. So this one is good. So functions are 3 and 4. Not functions are 1 and 2. And I already explained why. X equals 2 has 2 different outputs. X equals 6 has 2 different outputs. X equals 2 has the same thing with 1. 1 has multiple outputs there. Not good, not okay. Last 2, I want you to graph for me here. This is what I graphed before. On the set of axes below, graph me the absolute value of x minus 3 plus 2. So we go to y equals, math, number, and there's our absolute value of x minus 3 plus 2. So there's that V-shaped curve, but since I want you to graph it, I actually need a table of values. And I got to make sure I get that turnaround to get those repeating x values there. I think that's perfect for me. There we go. So let's plot these points now. Let's plot these points. Negative 2, 7. And from there, I plot these points. I know I'm doing it fast. That's because I've done this before. And since it's an absolute value graph, it should have that V shape. It should have that V shape that I have here. So it should be that V-shaped absolute value graph. It's 2 different lines coming together at that one point. Graph this function, negative x squared minus 6x. So again, whenever I ask you to graph something, let's go to our calculator. Negative, let me clear this out, negative x squared, I believe it's minus 6x. So if I hit graph, this is what I should be making. I should be making that U-shaped parabola there. Again, I'm going to go to my table. I'm not graphing negative 91. I'm going to find some nice values. There we go. That looks good. Negative 7. There we go. I'm going to copy that over. So again, I'm going to find those nice values that I can actually plot the points for. Negative 7. 1, 2, 3, 4, 5, 6, 7. Down 7. Negative 6, 0. Negative 5. 1, 2, 3, 4, 5. Negative 4, 8, 1, 2, 8, 9, and then everyone starts matching up again, 8. So I'm just going through matching up all those values with the same corresponding value, y value, to get that symmetry of that parabola. And your parabolas would be a little bit nicer than mine, and again, it's curved here. It's nice and curvy there. And you actually cross through the point. I just have really bad writing on my surface right now for some reason. So that's how you graph functions. When we graph functions, we go to y equals. We go to y equals and we type in graph, and we can go look at a table. All right, folks. Hopefully this was some good review and you got some answers to questions that you had, and I'll see you in the next video.